we'll talk about neural nets. If you've been conscious, for recent times, you've heard about neural network learning in the context of artificial intelligence, AI, whether in image recognition, is this a picture of a cat? Speech recognition, Alexa, what's the weather tomorrow? And LLMs, hey, ChatGPT, would you enslave humanity? I won't go into much detail here. The field is huge, rapidly expanding in lots of different areas, but you can quickly learn some of the basics. Both the costs and the benefits are really large. Costs are large since they have a huge number of parameters to estimate and need huge amounts of data to train them. All those interlocking estimation take a lot of knob twiddling and computation, but they are very useful. The models were originally developed to recognize handwritten numbers. The U.S. Post Office wanted machines to be able to read the zip code on letters instead of having the job done by humans. But the range of applications has grown much wider since then. The structure of a neural net starts with all the input values on the left-hand side. Those are restricted to all between 0 and 1, so standardized. The model outputs some values shown on the right-hand side. I'm showing just 2, but there can be many, many more. In between are hidden layers. The number of layers and the number of nodes within each layer are hyperparameters that we can set. Obviously, those can be further tuned, just like our previous models had hyperparameters that could be tuned for specific tasks. Each node takes in a bunch of values and outputs a number between 0 and 1. Each node's input-output function is not linear, which is one of the strengths of this type of model. If it were linear, then we could compact it down, but the nonlinear relationship between each node's inputs and its output gives the model complexity. While that sounds fancy, we've already seen a class of models that take in a bunch of values and output something between 0 and 1, logit models. Each node in the model of a neural network is often just a logit model. So while LLMs are often presented as effing magic, and their ability to handle complex problems sometimes seems startlingly awesome, at base, they're often just a real big collection of logit models. I mean, not always logit. Some other similar functions are used. It's an obvious change to be explored, but estimating all these logit models is really complex since, as the previous picture showed, there are a lot of connections. Any change to one node will propagate through the whole model. It's a good thing that computers are really fast at doing computations. The original idea of a neural net was that it was how animal neurons worked. That was decades ago. Since then, the field has added a great deal more complications. So if you want to know how our brains work, go talk to a neuroscientist here. But we can appreciate a bit of the complexity. We've talked about how a random forest model will take a while to be estimated, and that's just a bunch of tree models, which are individually pretty simple to estimate, and only one layer. We talked about how logit models are more complex to estimate compared with simple linear models. So it won't be a surprise to find that something like a forest of logit models with multiple layers would be tough to estimate. The other intuition that carried over is that we discussed how random forests are really difficult to interpret. Why did the model produce some prediction? Neural nets are just tough, even tougher to interpret. I'll give a bit of code in R, but it's not the preferred method of estimating these models. Go to Python if you want to do some. But R has a package, neural net, you can add. Then some basic coding following the usual pattern that you come to expect. Provide the formula, which is the dependent variable that we want to predict, along with the input variables. Here are only 4 of them. They all got to be standardized properly. Tell which data set to use. At least for me, I had to keep that quite small. Then the hidden piece of the command tells it how many layers and nodes. This example uses 4 nodes in the first hidden layer and 2 in the second hidden layer. The output provides a picture of the nodes that were estimated. A last thing to contemplate, I hope this bit of learning helped. But don't fool yourself that it's only a bit. If the metaphor a random forest of logit models made any sense to you, that's because you've done a ton of learning already. You've already estimated a whole bunch of different models with many parameters and methods. You're already at the level that the you of 4 months ago would have described as effing magic. Congratulations. Keep on going. Keep learning.